Hey maths fans, we're looking at arc length and sector area. So these are parts of the circle. Now, arc length could be a minor arc. So if I join these 2 points around there, that is an arc. So if we maybe call that point A and that point B, this orange line would be the minor arc AB. You also get a major arc between 2 points, which is kind of the bigger one. So look out for minor arcs and major arcs, but basically it's a part of the circumference. An arc length is part of the circumference. So if I wanted the arc length let's go for the minor arc AB, what I need is what fraction of the whole circle have I got here? Well, I know that for a whole circle, the circumference is pi times the diameter. Or you may see it as 2 pi r, whichever you use for the circumference. So the circumference, the whole circumference, is pi d, or 2 pi r. I've got a fraction of that circumference, and that fraction is theta out of the whole circle. So whatever my angle is, divide that by 360 and times it by the length of the circumference. That's it. Theta over 360 times pi d. That is how to calculate an arc length. For the sector area, the principle is the same. We've got, if I had the whole area of this circle, I would have pi times the radius squared. But if I haven't got that, if all I've got is, let's say I've got this sector area here, AOB, well, I've got this fraction of the whole circle. All you're doing is working out what fraction of the whole circle you've got, and then using your formula for area of a circle, or if you're doing an arc length, your formula for circumference of a circle. Let's see that in practice with an example. So the length of the arc AB. So length of the arc, this is to do with a part of the circumference. So I know that that is the pi d one. And I know that I'm dealing with 55 360ths of a circle. So always whatever the angle at the centre is, over 360 times pi d. Now just be a little bit careful here because we've got a radius of 5, so my diameter is going to be double that. If you imagine the whole circle, the diameter is 10. So I'm doing 55 360ths multiplied by pi times 10. And when I type that in my calculator, I end up with 4.80 centimetres. So that length of that arc is 4.80 centimetres. That's it. That's length of arcs. Now we'll have a look at the area of a sector. Area of a sector, we're going to be using the formula for area of a triangle, so pi r squared. We're still using that 55 over 360 and then multiplying. So all I do is substitute those values in for the radius times pi times the radius, which is 5 squared. And when I type that one in my calculator, I get 12.0 centimetres squared. Worth checking you can get that for those two examples. So that is it. That is arc length and sector area. Let's have a look at a more challenging question where we're going to work backwards from one formula and then use the other formula. So much more tricky, this question. So we've got the length of the major arc AB is 52 centimetres. So all the way round AB, the major arc, not this minor arc that would go through here. So all the way around the major arc, we have 52 centimetres. I want to know the angle at the centre. I want to know this angle here. That's what we're going to be finding. So if I use my formula, theta over 360 times pi d equals that arc length. And the arc length is 52. So now I can work back from this by substituting in the value for d. Well, if 12 is the radius, then 24 is the diameter. So I've got theta over 360 times pi times 24 equals 52. Now if I rearrange this, I'll take 52, I'll divide by pi, divide by 24, and lastly multiply by 360. So do a bit of rearranging there to find theta, and we find that the angle there is 248.3 degrees. Now that I've got that angle as 248.3, I can find the area of the sector. So I'll do 248.3 over 360 times pi times the radius squared. And if you want to try that one, you should get 312 centimeters squared. So there you go. That's a much more tricky example where you have to work backwards. But as long as you're comfortable with rearranging formulas and you put all the information in bit by bit, you should be able to get there. Arcs and sectors.